So, welcome to the seventh session. So, here we are talking about the double story frames. So, how to determine and how to analyze the double story frames. An important thing, the Carney's method is very best or suited method for the indeterminate structure as well as the story sections structures. Maybe portal frame, maybe double story, maybe double base, double stories. So that will be a good method for analyzing the stories. So these are the steps involved in the calculation of or analyzing the structures by Carney's method. So here, analyze the double story frame using symmetry as shown in figure 1 by Carney's method. Draw BMD. So here check. So the A is fixed, B is, so we can take as a continuous or rigid, C is continuous or rigid, D is rigid, E and F will be the fixed moment. So by using symmetry, so exactly at the center of the span, we will take a section. So where we have to calculate the stiffness for the symmetrical frames. The K value for BA, that will be I by L, BC will be the same. So only condition, CD dash, that will be the half of original K value, and K BE dash is equal to half of the original K value. So this value is very important here while you are considering as a symmetry, because it will be very simple. While you are calculating the 50% here and the 50% will be the left hand will be the values, and that same will be at the right hand side. So there is no need to calculate the D, DC, D, EF and FE like that. So using symmetry, whatever may be the left side, that will be directly you can put as the same value in the right hand side action. So here, we are calculating the fixed end moments. Only the BE and CD will be there. So 360 and 360. So MF, AB, BA, BC. So all the vertical columns, vertical structures should be equal to 0 because there is no any loads there. If there is a load, you have to check and you have to calculate the fixed end moments. So if there is no load, so you have to consider the 0 value. So MFBE and MFCD minus 360, there is no need to calculate the EB and DC value because we are going for the symmetrical section. So now come to the joint B and joint C. In the figure, we have to check for the B. So how many members are connected here? BA, BC and BE dash. So we have to calculate 3 rotational factors, BA, BC and BE dash. And for the joint C, CD dash and CB here. So BA, it is K value is equal to K, BC K value is equal to K. For BE dash, K is equal to half of original K. And you have to calculate the K dash CD is equal to half of CD. So here BA I by L, so you have to take this. BE dash, the I is 4I, half of original K, 4 into I by 6, so you will get this value. BC I by L, CB I by L and CD. So where the section will be symmetrical, so that will be, those members will be affected here. So you have to calculate the value. So in the next step, so we have to calculate the MFB. So here the MFB is the summation of MFBA, BC and BE, and for MFC, so this value, MFC, summation of MCB and MCD. minus 360 plus 0 you will get minus 360 minus 360. So these are the rotation factors. These three are the rotation factors. So here while calculating you will come by down to up, otherwise up to down. There is no any problem. So while you are considering starting from here, so this will be the far end value. No sir, I will start from this. If you start from this will be the far end value. So m dash d dash c is equal to 0, e dash b is equal to 0, m dash ab is equal to 0. So you can start from b, otherwise you can start from c. If you are starting from here, so this value will be the far end. Initially it will be 0, so you will get this value. Now come to here. So what they calculated, that will be the far end value. So here there are three values are there, far end values. One is for the joint B, E dash B, CB and AB. So these three are the far end values. So 60, 60, 60 because so we have come from B. So rotational factor will be the same. If the rotational factor is same, the value will be same. So joint C. So see here that 60 will be the far end value. So in this case, while we are calculating 360 into 0.166, you will get 60 is the far end value. What you have to do, minus 360 plus 60 multiplied by 0.25, you will get 75. If the rotation factor are same, there is no need to calculate here. So directly put this value here. Here also. So 360 into 0.166, you will get 60. There is no need to calculate here. These value will be the same values, because when you have a same rotation factor, there is no need to calculate again here. Because for the joint B, only CB will be the far end value. For all these three members, only M dash CB will be the far end value. For joint C, instead of 3, only M dash CB is the far end value. So you have to calculate this. Joint C, 60 is the far end value. Next, if you have a 75 in the second iteration, initially it was 0, 75 will be there. 360 minus 360 plus 75 multiplied by 0.166, you will get 47.5. So here there is no need to calculate, directly we will put 47.5, 47.5 here. So in the second iteration you will calculate this, and in the similarly in the third iteration and fourth iteration you will get the nearly values. So consider the fifth iteration will be the final values. So calculate the final net moments. MAB is equal to MFAB plus 2M dash AB plus M dash BA. So you will get the final moments 46.95, 93.9, 172.15, 203.2, 266 and 2. So these are only at the left sides. So this will be the symmetry. So we are calculating these values, left hand side values. Directly we can put the right side values because it will be symmetrical. So what the value at the left side from the symmetry, so same value will be get at the right side. So this will be the bending moment diagram. Thank you.